Okay, gang, Dr. Darbro again. Another pretty brief video, or at least I think it's going to be brief. And the topic of this video is sampling distributions, again, for proportions and bouncing this off the central limit theorem. But our focus in this video is how do we handle z-scores for these distributions. The notation gets a little strange, but we'll get through this together, okay? Let's think about where we've been and what we've done. So far, we've looked at z-scores for simply a raw score, and I would like for you from here on out to start thinking about that as when n is equal to 1. And the z-score that we have there is just x minus mu over sigma. And we've used that before in the class. Now, as we get into larger samples, say 2 or greater, we express our measurements collectively by using the mean. And this is where the notation from the central limit theorem for the sampling distribution or the distribution of sample means comes in. So the z-score for those types of problems is x bar, which is the mean of the 2 or greater measurements, divided by mu, which is the population mean, divided by the standard error. So let's see what happens when we work with proportions. And you really think about it, the z-score formula for proportions should be relatively clear. It's z equal p hat, which is our sample. Seems like that always comes first, minus p, which is what we describe our population by, and divided out by the standard error. So if you think about, again, the form for z-scores for proportions, it should be pretty clear why we come up with this formula. All right, let's work a problem. So again, I'm sticking with the Facebook users deal. So it says reports indicate, again, 32% of Facebook users update their status at least one time per day. Random sample of 1,000 Facebook users is selected, and 325 report they update their status at least one time per day. So our goal here is to be able to find and interpret the z-score for this sample proportion. Well, at the end of the day, this is a lot of plug and chug. And what I've done is use the formula. So guys, let's think this through. In the upper left hand, the 0.325, that's our p hat. We subtract that from 0.32, which is our population proportion. And our standard error is 0.32 times 1 minus 0.32 divided by 1,000. After the second equality, I've simplified things a little bit, and I put this in my calculator to get 0.34. Now, the beauty of having this on the video is you can stop me, and I would highly recommend that you do this. Grab your calculator, try putting this in your calculator, and see, just make sure you can get the final answer of 0.34. Final thing we do here is we do the interpretation. And what we would say here is a sample proportion of 325 out of 1,000 is 0.34 standard errors above the mean. Well, gang, I can almost guarantee you this is going to be the shortest video that I'll put up the entire semester. So enjoy it, take care, and see you on the next video.